Okay, welcome back Science 30s to our next lesson in organic chemistry. This is 2.2, and today we're going to be talking about halogenated hydrocarbons. In the last video, we talked about naming pure hydrocarbons that we're just looking at C's and H's. But in this video, we're going to look at now adding a different chemical, which is going to be a halogen. Because this is going to be a halogen bonded to an alkane, these are called haloalkanes. So this is an alkane that just includes a bond to an halogen. If you're forgetting what the halogens are, if we look on the periodic table, they're the ones in this column, in the 17th column. What's common between all of those elements is they all have the same amount of valence electrons from our Lewis dot diagrams. So because they're in the 17th column, from our Lewis dot diagrams, we said they had 7 valence electrons. And they want to get to a full 8, so this is going to make it nice so it bonds to carbon, similar to how hydrogens would, where they're going to share that 1 electron and we're going to get those bonds. So it just takes up 1 bond when bonded to a carbon. Now for naming haloalkanes, we're going to name those halogens just like they were a branch. We saw branches before of different carbon chains like methyl and ethyl groups, and now we're just going to label these as branches of a halogen. The suffix that they're going to get on the end of it, though, is an O. So this takes the root word of the halogen and then adds an O. So for example, chlorine becomes chloro. Now before we go into how to name some of these, you may have heard about some of these before, because in previous science courses you may have heard the term chlorofluorocarbons. And now that we know that chloro and fluoro just means chlorine and fluorine bonded to a hydrocarbon, we have a better understanding of what they are. And usually when they're talked about in other science courses is their effect on the ozone layer. So what CFCs are, chlorofluorocarbons, is that they were previously used in refrigerants and aerosols, but they're no longer used because they have a damaging effect on the ozone layer. And this is sometimes a commonly misunderstood phenomenon, so we're going to go through what that is. So if we bring up the Earth here and bring up the sun, there's a thin layer of ozone, and ozone is just O3. So oxygen we breathe is O2. This has another oxygen bonded to it, and it's O3. Okay. Now this is often talked about and related to climate change, but it doesn't really have to do with the greenhouse effect as much as it does with radiation. Okay, so what it does, this O3 molecule, is that when we have all these types of radiation coming in from the sun, O3 absorbs some harmful radiation and only some of it gets through. So that's useful for us. It blocks harmful radiation. But if we release CFCs from things like aerosols and refrigerants, when it goes up into the atmosphere and mixes with O3, it breaks it down into oxygen. Now, oxygen isn't harmful. That's what we breathe. We need it to breathe. But now that it's not O3, it doesn't absorb the same amount of radiation. More of that harmful radiation can get through. So that's the problem with having damaging or thinning or even holes in the ozone layer, is more damaging radiation can get through. Doesn't really relate too much to greenhouse gases, which sometimes it gets lumped into. So good to understand here the effect that it has on ozone and how that lets more radiation through. And now that we understand the effect of chlorofluorocarbons or CFCs, let's talk about how to name these haloalkanes. The steps are pretty much going to be the same as what we saw in the last video for just different types of alkanes. And here's the steps that we followed in the last video. But now we're just going to name those branches differently with naming the halogen and adding that O at the end. Okay, so if you're looking for a recap of those, maybe just check out the last video. Otherwise, we're going to move on with these steps. Okay, so looking at this example, the first step is to determine how many carbons I have in the parent chain. This one's nice, just a chain across. I see that there are 4 carbons. Remember that 4 carbons, looking at your data booklet, gets the prefix of bute, so this would be butane. But now we see that we do have that group of bromine right there. We have that Br. So that is going to get labeled as a branch, and we want to put it on the lower number. So I check numbering the carbons this way, and I get the bromine on the 2. Just want to check to see if that's the lowest number. What if I flip the numbers the other way? I would get the bromine on the 3. That's higher than a 2, so let's go back to the other way. There we have bromine on the 2. Now we have to change the suffix of that. So instead of bromine, we're going to call it bromo, which comes down there. So there is a bromo on the 2, and it's butane. This would be called 2-bromobutane. I can see that branch is just like those methyl and ethyl branches that we talked about in the last video. Okay, let's try another one. This one a bit more complicated. We have a branch with a carbon and then we have a branch with a halogen. So let's try and put these both together. Same first step, try and find the longest parent chain. So I circle there and see that I have 1, 2, 3, 4, 5, 6 carbons in a row. That's my longest chain. And then I have 2 branches. I have a CH3, which we saw from the last video was a methyl group. And then I have an F on the bottom over here, which is a fluorine, so it gets called fluoro. Now let's look at how to number the carbons. How about if I come this way first? If I go 1, 2, 3, 4, 5, 6, I have the methyl on the 4 and the fluorine on the 5, or the fluoro on the 5. So 4 and 5, let's switch it now to the other direction. And I can see that the fluoro is on the 2 and the methyl is on the 3. This is lower numbers, so we're going to keep this orientation. That means I have a fluoro and a methyl. Let's put them in alphabetical order. 2 fluoro, 3 methyl, hexane would be the name for that chemical. And now for our last example of this video, we see this even further complicated one with seems like a pretty long chain and then a long branch coming down. We may think initially that this would be our parent chain because it's going straight across, but when I look at the length of that one and then look at the length of if I circle this parent chain, this one ends up being longer with 1, 2, 3, 4, 5, 6, 7, 8, or if I went the other way, I only got 7. So this is the longest chain of carbons in a row. That's going to be my parent chain. So then I have a branch here of looks like 2 carbons, so that's going to be an ethyl, and then a bromo over there. So I have ethyl, and then I have bromo, because bromine changed to bromo. And now I got to number the carbons, and again, we might look this way initially, getting the bromo on the 2 and the ethyl on the 5. Let's just check the other direction. So I'll remove those and put this one this way. Then I get the ethyl on the 4 and the bromo on the 7. Those are higher numbers than when I've numbered it originally. So let's switch it back to those. Then I get lower numbers for my branches. So I have 2 bromo and a 5 ethyl. We have to put them in alphabetical order. So the bromo would come before methyl. So when I put the name together, I get 2 bromo, 5 methyl, octane. And that's all we have for this video. So I hope that helped you to understand how to name haloalkanes. Thank you so much for watching this video, and I will see you in the next lesson.